The secret to building highly responsive systems. Martin Thompson. I'm Chris Athanas. I'm a KMP developer. Tech support said they're coming out for that for sure, 100%. They told me they promised really this time. I'm going to be reviewing this video by Martin Thompson. I've never watched it before. Go from DevTools Made Simple. He does little clips of like architecture, software architectures, videos, which haven't been coming out lately. There hasn't been too much of this. Maybe this is kind of fallen over, or maybe the software industry since it fell over in 2023. Maybe this has been not a thing, but I don't know. Let's listen in.
Now, when it comes to performance, I think this sums up nearly the entire picture for me. This is my life a lot. I end up flying and I end up going to border control. And with this, you can explain everything that's actually relevant about performance. So we'll hear about latency, we hear about response time, different things like that. So what is the difference between these? We just interchange them, but there is actually a distinct difference if you look at queuing theory.
All right.
So if I join one of these queues, I'm going to be doing a number of things, and each of those things you can measure them in different times. So how long I'm waiting in the queue is my latency. That is how long I am latent to do something. When I get to the front of the queue and I go to the desk, I'm now being serviced. That is the service time of the system. Those are distinctly different. Now, what's response time? It's latency plus service time. And if you want to start modeling these things right and starting doing some real math on it, we have to break these down and understand what we're dealing with and how we deal with it.
That's a nice way of thinking about two phases where you're waiting to be served, then being served, and that's your whole thing. Then you define what those like. People throw those meanings around a lot. I like this guy already. He's already defining the terms. Super useful to think about these things in this way.
And so then what is parallelism? Well, I just have more queues to go to here. It's actually the perfect model for this. You also talk about things like work stealing. Well, what if one of these queues is too long and another one's too short? You'll usually have someone come along and tell you to move from this queue to another queue. So all these sorts of things, we do this in reality. But quite often, it doesn't really manifest itself properly in software, yet it's really, really simple. Before I had this little chat, who thought response time and latency was the same thing?
I mean, I've heard them both used interchangeably, but yes, I've heard them both be response time and latency being the same thing. I've definitely heard that. We'll use that quite a bit. How about you?
It's okay to admit, a lot of people probably do. In fact,
For sure.
most people use latency to describe response time.
Yeah.
Latency, look at the word, look it up in the dictionary, is about being latent. You're waiting.
Interesting. That's so cool. I never knew that. I love this kind of stuff.
Time has to include the service time as well. And once we understand these, you can actually design systems better, and you can optimize and profile and do all of the right sorts of things. So in particular, let's look at queuing theory for a second. So whenever we start using the system, the more we use it, we notice that our response time starts to slow down. Well, why does it slow down? Because
I love DevTools Made Simple. I love his B-roll.
actually, the service time is the same, but you start joining queues. And the thing is, if you go to something and
right, I mean the processing time of each one of the nodes is still the same, but as you queue up, yes, you're gonna wait. You're gonna be waiting longer as more people are in line, of course, because people are gonna start waiting in line. Yes,
being used more often, so the utilization is going up. The probability of someone being in the queue is greater. So if you're only using something,
more people are using it. Yes, if more people are using the service, there's gonna be more of a likelihood someone's gonna be using it. What?
At like 10% of its utilization, the chances are there's no one in the queue.
Yeah.
So you get a good response time because you're not latent. So the secret to having very responsive systems is keep the utilization down. Don't have them running at maximum utilization. And we can see here on this graph that once you go about sort of 60 to 70% utilization, things start getting pretty bad. This also works in reality for projects and people and everything like that. If you run your team,
Kubernetes! Yeah. I mean, if you get this kind of problem, you're doing well. If you're getting utilization problems, that means you have customers, you have servers, you have a problem you're trying to solve. Hopefully, you're getting paid for those things. But this is a good problem to have to deal with. You hopefully have it, and it's a good idea to think of it this way. Let's keep going.
60% utilization. If you need them to respond quickly to a need, guess what? They're not going to be able to. It's math. You cannot run away from it. This is just probability theory. It's 100-year-old math.
Cool.
And it's well described. And so you start breaking these things down, we can get that. So if you're designing, say, a financial trading systems, you want to have it so over-provisioned that whenever some work comes along, you want to have utilization so low that you're pretty much just going to get hit with service.
Or you have enough scalability, provisioning scalability, so you can take the hit and scale it up quickly. I don't know if you want all the hardware running there all the time, but someone's gonna have to have the hardware running there somewhere. But maybe you don't have to have it if you want to scale it up on demand. That's, I guess, the idea. Let's keep going.
Time. If you end up having your system working quite busily at that point in time and you get a burst of traffic coming in, your utilization is quite high, you're going to queue and your response time is going to go. So you've got to be aware of these, and we'll look at how we measure them and deal with them later on. So that's kind of one of the pro tips, is always ensure you have sufficient capacity. And by having sufficient capacity, you will keep your utilization low and you can respond quickly. So if you want a service that's going to respond quickly, utilization needs to be kept low.
I mean, that's kind of, I mean, of course that makes sense, right? If you've got 5,000 people coming through at 9 a.m., you want to make sure there's all of the windows, all the aisles are open on your checkout lanes. And as soon as rush hour is over, you can let those people go home, like everybody except for two. Yeah, I mean, this is not unusual. But I like the video. I like just breaking it down, beginner level stuff. I don't know if it's beginner level, but I guess people miss it because it's computers. It's like, no, it's just lines and people processing at the queues. I have a video called the Universal Architecture. That's basically what we were replacing with these machines, is people. I know it's hard to believe. Give me a like and subscribe, and I'll leave links to all the stuff below.